Hello and welcome. My name is TheSefa, and this is my final year project, PDFreak AI. It's a system that detects and analyzes malicious PDF files using AI, machine learning, and automated reverse engineering. PDFs are everywhere, but they're also a major cyber threat. Attackers often embed malicious JavaScript, shellcode, or phishing links in PDFs. Unfortunately, many security teams can't afford expensive tools like VirusTotal Premium. I wanted to build a free, open source alternative that uses AI to give detailed, actionable insights. So here's how the system works from the user's perspective. A user uploads a suspicious PDF file using the web application. Behind the scenes, the file goes through a feature extraction pipeline using tools like PDFiD, peepdf, and pdf-parser to uncover signs of malicious behavior like embedded JavaScript, suspicious links, or shellcode. These features are passed into a random forest classifier which predicts whether the file is safe or malicious. If it's malicious, the system digs deeper. It uses AI, specifically a Mistral 7 billion language model supported by a malware knowledge base, to analyze what kind of attack it is and also suggest response actions mapped to MITRE ATT&CK techniques. For complex files, it even reverse engineers embedded payloads using Ghidra to find system API calls or obfuscation. Finally, all this is presented back to the user as a clean, readable report through a fast and responsive web interface. The system starts with static analysis. I use tools like pdf-parser, peepdf, and pdfid, just like I illustrated in the previous slide, to extract features without executing the file. I look for signs like embedded JavaScript, entropy levels, suspicious URLs, and obfuscation. These features help detect hidden malware and serve as input for the machine learning model. Here, I have some code snippets of the actual feature extraction script, which I will further later on dive deeper into, and also a sample of the extracted features. The extracted features are passed into a random forest classifier trained on over 1,200 labeled PDFs. It predicts whether a file is malicious or benign. I use predict-proba to get a probability score and adjust the threshold to favor catching malware, since false negatives are more dangerous in security. This snippet here shows how I trained the classifier. I built a pipeline that scales features, selects the most relevant ones, and fits a random forest model. Then I tuned it using a 5-fold grid search CV. The model that performed best on F1 score is used to classify new PDFs as either malicious or benign. If the PDF is malicious, the AI analysis begins. I use a Retrieval-Augmented Generation pipeline, or RAG. The system searches a vector database containing past malware examples and MITRE techniques, retrieves the most relevant entries, and sends them to the Mistral 7B LLM. This lets the AI generate rich analysis, type of malware it is, which MITRE technique it uses, and what actions a SOC team should take. Here's the Mistral output for one of the malicious samples. As you can see here, we get the attack type, a description of the potential behavior, MITRE attack techniques, and also SOC recommendations. For more complex samples, I extract embedded files and run them through Ghidra in headless mode. This allows me to identify obfuscated payloads, system API calls, or encoded shellcode. This script uses Ghidra's headless API to decompile functions and scan for suspicious system calls. In this example, I'm checking for create process A or when execute, which are often used by malware to launch new processes on victims' machines. Here's the front end of PDFreak AI. It's built in React with Tailwind CSS 4. Users can upload a PDF and instantly see results. Verdicts, thread classifications, MITRE ATT&CK mappings, and SOC recommendations, all in a clean, easy to read format. Here's a live demo. You can drag and drop a PDF file, whether it's a raw PDF or a zipped, compressed PDF. Or you can just click in here and select the file from your Finder. I'll select this file right here. Once you upload that, the file is then sent to the back end. In under seconds, we get a result. It's malicious. We get file overview, behavior indicators, quick stats, and also the AI analysis summary once we scroll down. As you can see here, it's classified as an exploit, which is shellcode injection. We get key indicators, recommended security actions, and also relevant MITRE attack techniques. This snippet here shows the heart of my feature extraction. I use multiple tools and custom logic to gather static indicators, from JavaScript blocks and shellcode to phishing links and stream object patterns. Entropy helps detect obfuscation and structural analysis, with peepdf giving deeper context. All of this is compiled into one feature vector for classification. So I faced some tough challenges, from handling obfuscated scripts to building a good training set and integrating Ghidra. Looking ahead, I would like to add dynamic sandboxing or even support batch PDF uploads, and also improve the model's accuracy using additional data sets. So to wrap it up, PDFreak AI combines traditional feature engineering with a modern AI to detect and explain threats hidden in PDFs. It makes malware analysis faster, more accessible, and easier to understand. I'd like to give a big thanks to Professor Panos and also Endeavor IT Security, especially Kai, for guiding me through this project. Thank you so much for watching, and I hope you enjoyed the overview of my final year project, PDFreak AI. I'm happy to answer any questions down in the comments. Thanks.